Hello friends, welcome to lesson 0.4 where we review some basic trigonometry stuff. Start with your old school SOHCAHTOA. Now something you need to know about trigonometry. There's kind of two worlds of trigonometry and they do overlap. You have trigonometry that's done with right triangles, and then you have trigonometry that's done on the circle, like your unit circle and all that stuff. With all your trig functions, sine, cosine, tangent, blah blah blah, they are defined one way on the triangle and another way on the circle. And there is a connection, there are relations there, but they do have two kind of different worlds that they play with. So SOHCAHTOA right here, that's in the world of basic right triangle trigonometry, where sine is opposite over hypotenuse, so cosine is adjacent over hypotenuse, CA, and tangent is opposite over adjacent, TOA. There we go. SOHCAHTOA. And that works when we're talking about right triangles and we have a hypotenuse and an opposite and an adjacent. However, we also talk about these in the world of circular functions where we don't have a hypotenuse, we don't have an opposite or an adjacent because we're talking about a circle, not a right triangle. When we're talking about circle world, then sine is y over r, cosine is x over r, and tangent is y over x. So those are different definitions, they have relations, but you need to know both. Let's go up and talk about some examples with our right triangles. So sine is opposite over hypotenuse, so if I look at my example over here, the opposite side is 4, the hypotenuse is 5, and that's it, we're done. Cosine, the adjacent side is 3, the hypotenuse side is 5. That's it, we're done. Tangent is opposite, which would be 4, over adjacent, which is 3. There we go. Now secant. Secant is related to the cosine function. Now some way I remember it, your C's and S's are flipped. So sine goes with cosecant, SC. Cosine goes with secant, SC. They're paired together. So secant is your cosine flipped. So I take my cosine, 3/5, flip it to 5/3. And there you go. Now let's talk about circular trigonometry. We have some new definitions, but once again, your cosecant is your sine flipped, secant is cosine flipped, cotangent is tangent flipped. You also have this definition over here for r. By the way, that is just your Pythagorean theorem. So if I have a circle here, and I have my r, my radius, if I draw this down, this is x and y, that is just Pythagorean's theorem. X squared plus y squared equals r squared. A squared plus b squared equals c squared. And then you solve for r, so then you r equals the square root of x squared plus y squared. That's where that comes from, just Pythagorean's theorem. Talk about a couple examples. We want to find sine, cosecant, and cotangent through this point. So the first thing we need to do is find our r. Square root of x squared plus y squared. Make sure your -5 is in parentheses. Excuse that, Bill. So then we've got 25 plus 4. So r is the square root of 29. You can simplify that to a decimal. You don't have to. Just remember that if you do it to a decimal, 3 decimal points. Always, always, always. So now I have sine of theta with my new definition is y over r. So y is 2. That's the y coordinate in the point that it gives me in the problem. R is square roots of 29. Now, clarifying point. I have a lot of students ask, do I need to simplify that? Because I know teachers in the past have drilled into you that if you have a root in your denominator, you need to get it out. That you should never have roots in the denominator. Well, guess what? AP graders don't care. You do not need to simplify or rationalize that denominator. You can leave the root in the denominator and you're fine. So, there's that. Cosecant of theta, cosecant will be sine flipped, so r over y, which just means I flipped the one I got for sine. And cotangent of theta is tangent flipped, so x over y. So my x was -5 and my y coordinate was 2. And there you go. In the next video, we'll talk about your special right triangles, 30, 60, 90, and 45, 45, 90, which really should be memorized, and reference.